Dear students, I'm going to present to you the concept of the expected value of a real valued function of a random vector. And I would like you to concentrate on this one because there are a number of concepts involved. सबसे पहली बात यह है कि जो मैंने अभी कहा, it's a straightforward extension of the concept of the expected value of a function of a random variable. यानी जो univariate case में जो होता है उसी की एक extension है to the bivariate or the multivariate case. So let us consider the bivariate case and let x1, x2 be a random vector, and let us define capital Y equal to g of x1, x2 as a real valued function of x1 and x2. देखिए, इससे आपको परेशान होने की ज़रूरत नहीं है. G of x1, x2 can be any function. It can be very simple. For example, y is equal to x1 plus x2, y is equal to x1 minus x2, y is equal to x1 square minus e raised to x2. कहने का मकसद ये है कि some combination of x1 and x2 which can be regarded as a function of x1 and x2, इसका नाम हम अगर y रखें तो उसके फौरन बाद हम ये नोट करते हैं कि y जो है then it is a random variable, इसलिए कि x1 और x2 if they are themselves random variables, then obviously this combination of them, whatever it is, that is also a random variable. And if it is a random variable, then we can determine its expectation by considering the distribution of this random variable. But students, first and foremost, let us determine the conditions under which the expectation of y will exist. Existence भी तो देखनी है ना, क्योंकि sometimes you might try to do it and it may not exist. So let us commence this particular discussion with first looking at the conditions that are required in the case of a single random variable. A random variable x will be said to have a finite or an infinite expectation, according as whether e of x is a finite number or is it not a finite number. If it is finite, then of course we will say that the expectation or the expected value exists. However, if it is infinite, if it is not finite, we will say that the expected value of x does not exist. पहले तो ये नोट करें कि ये जो लफ्ज़ हम बोलेंगे ये हम कब कहेंगे. उसके बाद जाहिर है कि अगर ये बात है कि if it is not finite, then we say that it does not exist, then naturally we would like to determine the conditions under which it will be finite. So what is the definition of the expected value of x? We all know that in the case of a discrete random variable, e of x is equal to summation xi into p of xi. And in the continuous case, it is the integral of x into f of x. So, students, this e of x will be finite if our summation or our integral converges absolutely. अगर ये absolute convergence अगर हो रही है, then e of x is finite and we say that it exists. Then naturally, the next question that comes to mind is, what is meant by absolute convergence? ये क्या चीज है? What is absolute convergence? Well, the concept of absolute convergence is not so difficult. It is as follows. The term absolutely convergent describes a series that converges when all of its terms are replaced by their absolute values. All right? Let me say it in a different way. The term absolutely convergent describes a series for which the sum of all its terms remains finite when all the terms have been replaced by their absolute values. Whatever I'm now saying is also obviously to be represented in algebraic form. And students, it is not so difficult. So if we let capital X be a random variable of the discrete type with probability mass function P of xk equal to the probability of capital X being equal to xk, where k itself is 1, 2, 3, and so on, then if the summation of the modulus of xk multiplied by p of xk, the modulus of xk multiplied by p of xk, इस तरह के all possible products का जो sum है, if this particular summation is less than infinity, in other words, if this particular summation is finite, then we say that the expected value of x exists, and we write mu is equal to e of x is equal to summation xk into p of xk. वही फॉर्मूला जो हम जानते हैं, लेकिन अभी मैंने आपके सामने वो कंडीशन रखी कि जिसके होल्ड होने पर हम ये आगे ये बात कह सकते हैं. Similarly, if it is a continuous variable, then if the integral from minus infinity to infinity of the modulus of x into f of x, the modulus of x, not just x, but the modulus of, in other words, the absolute value of x into f of x, iska integral, agar, if it is less than infinity, in other words, if it is finite, then we say that the expected value of x exists, and we write mu is equal to e of x is equal to the integral from minus infinity to infinity of x into f of x with respect to x. So the same formula that we are aware of. अब जो कुछ मैंने अभी कहा for a single variable x, similar logic applies for a function of the random variable x. So if g of x represents a function of x, then we will say that the expected value of g of x exists, and it is equal to the integral of g of x into f of x if it is a continuous variable, provided that the integral of the absolute value of g of x multiplied by f of x, if this integral is less than infinity. तो आपने देखा कि exactly जो पहले था उसी की extension. And now I'm in a position to talk about the expected value of a function of two random variables, x1 and x2. So if both x1 and x2 are continuous random variables, and they have a joint PDF small f of x1, x2, then we will say that the expected value of g of x1, x2, yani a function of x1 and x2, the expected value of this function exists and it is equal to the double integral of g of x1, x2 multiplied by the joint PDF f of x1, x2, provided that the double integral of the absolute value of g of x1, x2 multiplied by f of x1, x2 is less than infinity. Yani, again, a further extension of what I said before. And last but not the least, let us also consider the case when x1 and x2 are not continuous but discrete. So in a very similar way, we will be able to say that if y is equal to g of x1, x2 is a function of two discrete random variables, x1 and x2, then the expected value of y, in other words, the expected value of g of x1, x2 exists if the double summation of the absolute value of g of x1, x2 multiplied by p of x1, x2, if this double summation is less than infinity. आपने देखा कि everything falls in place, and I have tried to give you various concepts step by step, some general definitions, and then applying in our situation. And this is the concept of the expected value of a real valued function of a random vector.